Hello everyone. Today I am going to explain you to how to draw Lewis structures correctly. So before going into the lesson, let me remind you to subscribe my channel and to hit the bell icon to get hold of the videos as soon as it is uploaded. Let's try to understand how to draw the Lewis structure of carbon dioxide. The first step of drawing Lewis structures is to calculate the number of valence electrons associated with this formula. So as we all know, carbon is a group 14 element, so it has 4 valence electrons, and oxygen is a group 16 element, it has 6 valence electrons. But remember, there are 2 oxygen atoms, therefore we have to multiply this by 2. So altogether we have 16 valence electrons, and we should divide this by 2 to find the number of electron pairs. So we have 8 electron pairs. The next step is to draw the skeleton of this molecule. So when drawing the skeleton, what you should remember is the atom with the least electronegativity becomes the central atom. So as we all know, carbon has an electronegativity of 2.5 and oxygen has an electronegativity of 3.5 according to the Pauling scale. So then carbon will be the central atom and oxygen will be the terminal atoms. Then we have to subtract these 2 bonds from the total number of electron pairs. So we get 6 remaining pairs. So the next step is to distribute these remaining pairs starting from the terminal atoms until the octet is fulfilled. So octet is 8 number of electrons. So let's start distributing this. 2, 4, 6. Here we can see 2, 4, 6, 8. So octet is complete. So let's move to this atom. 2, 4, 6, 8, octet is complete. So we had 6 pairs. So 1, 2, 3, 4, 5, 6. All 6 are distributed. The next step is to find the charges on each atom. So here we know that oxygen is a group 16 element. So it should have 6 valence electrons. But here around this 1, 2, 3, 4, 5, 6, 7. So it exceeds 1 electron, therefore it carries a negative charge. So here also there should be a negative charge. So when it comes to carbon, carbon is a group 14 element. So it should have 4 valence electrons, but here around carbon we have only 2. Then it should be 2 plus. Then the last step is to minimize the charges. So in order to minimize the charges, we can make this lone pair as a bond, and we can convert this lone pair as a bond. But remember, when minimizing charges, make sure not to exceed the octet for second period elements. So after minimizing the charges, we get this structure, which is the most acceptable Lewis structure for carbon dioxide. Let's move to the second example. So let's try to understand how to draw the correct Lewis dot dash structure for this NO3 minus ion. As we know, the first step is to calculate the number of valence electrons. So nitrogen is group 15, so it has 5 valence electrons. Oxygen has 6, so altogether 18. Please remember, when there is a minus charge, we should add 1 electron. So altogether we have 24 valence electrons. So divide by 2 to find the number of pairs. We have 12 pairs. And then our next step is to draw the skeleton for this molecule. So nitrogen has an electronegativity of 3 and oxygen has an electronegativity of 3.5. So nitrogen will be the central atom and the 3 oxygen atoms will be the terminal atoms. So because of these 3 sigma bonds, we have to subtract 3. Then we have 9 pairs remaining. So we have to distribute these 9 pairs starting from the terminal atoms, completing the octet. 1, 2, 3, 4, 5, 6, 7, 8, 9. So all 9 are distributed, and the next step is to find the charges on each atom. Here we have minus, here we have minus, and here we have minus. And around nitrogen, we know nitrogen is a group 15 element, so it should contain 5 valence electrons, but here we have only 3, therefore it gets a +2 charge. Then we are moving on to the last step of this, that is minimizing the charges. So we can take this lone pair and make it a 1, and you will think that we can make this a 1 too. But please make sure that nitrogen is a second period element. So therefore we can't exceed the octet. So if we draw a structure like this, so you will get, so around nitrogen we have 2, 4, 6, 8, 10 electrons. So it is exceeding the octet. Therefore, this is not a correct structure. So make sure not to exceed the octet for second period elements. So then the correct structure would be this. So this is the most acceptable Lewis structure for NO3- ion. Let's see how to draw the correct Lewis structure for SO3 2- ion. So the first step is to calculate the number of valence electrons. So sulfur is a group 16 element, therefore it should have 6 valence electrons. Oxygen is also a group 16 element, so it should have 6 valence electrons, altogether 18. Because of this negative charge, we should add 2 electrons. So altogether we have 26 valence electrons, and we should divide that by 2 to find the number of pairs. So we have 13 electron pairs. Then the next step is to draw the skeleton. So sulfur is lesser electronegative than oxygen, therefore sulfur will become the central atom. And because of these 3 sigma bonds, we have to subtract 3 valence electrons. Then we get 10. So as usual, we should start from the terminal atoms. We should distribute these 10 electron pairs. 1, 2, 3, 4, 5, 6, 7, 8, 9. But 1 remaining. But there are no other terminal atoms to distribute that lone pair. Therefore, we should distribute that to the central atom. So our next step is to find the charge on each atom. So here we get minus, here also minus. But around sulfur, 1, 2, 3, 4, 5, but it is group 16 element. Therefore, 1 electron is missing, therefore it will get a plus charge. So the next and the final step, that is to minimize the charges. So we can make this lone pair a 1, and we are getting this structure. Which is the most acceptable Lewis structure for SO3 2- ion. Let's move to the last example in this video, which is ClO2F2+. So the first step is to calculate the number of valence electrons. Chlorine 7, oxygen 12, and fluorine 14. But because of the plus charge, we have to subtract 1 electron. So then we have 7 plus 12, 19, 33, but minus 1, 32. So we should divide this by 2 to find the number of pairs. We get 16 pairs. And then the next step is to draw the skeleton. So as we all know, according to the Pauling scale, chlorine has an electronegativity of 3, oxygen 3.5 and fluorine 4. So chlorine becomes the central atom in this molecule. So because of these 4 bonds, we should minus 4 pairs. So we get 12. So we should distribute this 12 pairs starting from the terminal atoms. Then the next step is to assign the charges. So here we get minus, here we get minus, here 1, 2, 3, 4, 5, 6, 7, no charge. Here 1, 2, 3, 4, we get plus 3. Then the next step is to minimize the charges. So we can make this a bond, this a bond. So we are getting this structure. So this will be the most acceptable Lewis structure for ClO2 F2+. And you will ask why we have exceed the octet here. But remember, chlorine is a third period element, so we can exceed the octet. So if you enjoy this video, make sure to hit the like button and share this among your friends. And if you have any questions regarding this topic, you can ask me in the comment section.